folks, welcome back to Physics with Captain Ron. I'm making this video to get you started on number 41, chapter 7 in your engineering mechanics homework. So what we're looking at is this bar looking doohickey thing with this external force loaded. That's a 7i minus 12j minus 5k in kilonewtons. And let's see, the question is to find the internal loadings at point E, which is right here in the center of that bar. Alright, so I think I would start this, like most of these problems, by dealing with the reaction forces. And one thing to take note of is, if we had the reactions at A, a free body of this piece of it would be very, very simple. So as we take a look at this structure, this thing right here, I believe this picture, this thing is designed to be a thing that can apply forces like this way and this way, but not this way. So this C here, we're definitely going to have a CX and a CY. Now I'm going to go through and talk about force reactions first, and then come back and visit moment reactions. Talk about this point right here. This thing's definitely going to have a BX and a no BY, but a BZ. Over here, this thing, at this point, we're going to have no AX, but an AY and an AZ. Now, right now, there's 1, 2, 3, 4, 5, 6 reactions, and you can only write, for this free body, 3 force and 3 moment reactions. So we're limited right now. I mean, we can't write any more reactions. If it had any more, we wouldn't be able to solve it. This thing right here certainly cannot do any moment about the z-axis. Conceivably, it could provide some sort of moment about both the x and y axes, but you'll see a term used in a lot of these problems that says proper alignment. If this thing is aligned correctly, like these things, you know, imagine this thing were loaded in such a way that it was putting some sort of torque here. Well, imagine this were like broken free, and this was allowed to move slightly and adjust, and then glued back down. See how the moment reactions would go away. Same can be argued here and here, and that's what they mean by proper alignment. So that's it reaction-wise. So first, solve the reaction problems here, and that does not look like that's trivial. You're going to have to write a bunch of equations. I'm kind of glancing at it here. Let's see, you know, try to do things like a moment equation about this axis right here. This is probably a good place to start. That axis. Because this force and these two forces go right through that axis. This one's parallel. You have this force times this distance, this force times this distance. This one's parallel. That's going to give you a nice, somewhat easy equation between these two. Oh, let's see, what else are we going to want to do here? Maybe write another equation about this axis right here. All right, that'll get rid of these two. This one's parallel, so you'll have this thing times this distance. Another parallel one, this thing times this distance. Then try, well, probably this axis right here. That'll give you another equation. And then try force equations, x, y, and z. I mean, that's about all I can tell you without actually doing the problem. Write a bunch of equations out and get that thing solved for those reactions, okay? Once you have the reactions, these are the ones you need right here, because once we have the reactions at A, we'll be able to figure out what's happening at E reasonably easily. So find those reactions at A, then come over here, draw a free body, cut it right through E. Oops. Darn it. Cut it right through E. directions there at A. And let's see, it says to include, I'm going to read this one more time. Determine the X, Y, and Z components of the internal loading in the rod about E. Boy, I would say force loadings, it's going to be a three-dimensional thing here. Let's put a, see, the direction of the shear force is not 100% clear. Let's put a three-dimensional force vector there. That looks like this. Let's see, that's a J for internal loading. Oh boy. Looks like we're going to have to put a three-dimensional moment vector on this as well. I'll just draw it like so. That's going to have an X component I, a Y component J, a Z component K, and then don't forget the reactions AX or AZ, AY. It's pretty well lit though, that's the other side of the bar. So I'd say force equations in the X, Y, and Z directions should nail down these, this, and this for you quite easily. Then write a moment equation about the x-axis will get you this, about the y-axis will get you this, about the z-axis will get you this. Once you get it down and you get these reactions, this thing looks a lot more complicated than it is once you have those reactions. It kind of looks like getting those reactions might be a PETA, but this part of it actually isn't so bad. So hopefully that will get you rolling. If you don't get this problem worked out, send me another email and I'll see what I can do about that. Also, by the way, when you write any moment equations, getting back to the entire free body, any moment equations in the z direction, don't forget this 3 kilonewton meter couple moment there. So anyway, hope that gets you working on that problem. Good luck.